Hi dear students, in this video I am going to talk about particle nature of electromagnetic radiation. This is the ninth part of the chapter, structure of atom. Particle nature of electromagnetic radiation. Wave nature of electromagnetic radiation is able to explain two properties of light, that is diffraction and interference. Wave nature able to explain two properties of light, that is diffraction and interference. Diffraction is bending of light wave around an obstacle. That is called as a diffraction. Interference is combining of two waves with the same or different frequencies to give different frequency light, different frequency wave. That is called as interference. So, but wave nature does not able to explain some other properties of light. Wave nature does not explain some of the properties of light. In that important properties are black body radiation, photoelectric effect, line spectrum of atom, variation of heat capacities of solids, as a function of temperature, this has been given by Kirchhoff equations, right? This is not there in the syllabus, chemistry syllabus. This fourth point is not there. So let us discuss about the black body radiation now. Black body is an ideal body which absorbs and emits radiation of all the frequencies. Black body is an ideal body which absorbs and emits the radiation of all the frequencies. Ideal black body does not exist, but the chemist has made a black body, that is a hollow sphere made with the metal which has a small hole in it, and inside it is coated with the platinum black or the lamp black. This is almost behaves 99% as a black body. Hollow sphere made with the metal which has a small hole in it, and inside it is coated with the platinum black or lamp black. When radiation of certain frequency incident on this black body, this particular body which is made by the scientists, then this will be due to internal reflections, it is absorbed and it is re-emitted through this hole only. So this is almost 99% which can behave as a black body. The black body radiation is clearly explained by the scientist's name is Max Planck by using his quantum theory. Max Planck is explained black body radiation by using is quantum theory. Is quantum theory. So according to the Planck, that when a solid is heated, it will emit a radiation of different frequencies. Students, according to Max Planck, when solids are heated, they will emit a radiation of different frequencies at different temperatures. For example, when we are heating iron rod, heating of iron rod, at lower temperature, it will convert into dull red in color. As the temperature increases, it is converted into bright red. Still we are increasing the temperature, then into orange, then yellow, progressively into white color, and finally at an elevated temperature it will convert into blue color. So students, if it is emitting different colors, means different frequency of light it is emitting, right? So when a white light is passed through the prism, a continuous spectrum can be obtained, in which the 7 color bands, each band is merged with the other. 1, 2, 3, 4, 5, 6, 7. 7 color bands are, each band is merged with the other. That is called as a continuous spectrum, which can be memorized as VIBGYOR. VIBGYOR, right? In this, violet color has minimum wavelength 400 nanometers and maximum energy, and red color has 750 nanometers maximum wavelength and a minimum energy, right? So from this it is clear that when an iron rod is heated, it is emitting the radiation of different frequencies. When it is the same frequency, when the radiation is a wave nature, then it should emit the same color. The brightness of the color should increase, intensity of the color may be increases according to the classical mechanics. When the solid is heated, it should emit same type of color, but it is not emitting the same color. It is giving a different color, means different frequency of radiations it is emitting. Students, only one factor on which intensity and frequency of radiation depends is temperature. Only one factor on which intensity and frequency of radiation depend is temperature. Depend is temperature. Here we need to discuss about one important graph, that is wavelength lambda versus intensity. Wavelength lambda taking on x-axis and intensity by taking on y-axis. So at two different temperatures we will get different graphs like this. This is at temperature T2. This graph, second graph, this is at temperature T1. Temperature T1. Here T2 is greater than T1. So at corresponding wavelength, a particular wavelength intensity, if you get this one corresponding value for T1, intensity is lesser than the same wavelength when we are considering the corresponding value on the y-axis for the T1 is lesser than T2. So at a lower temperature, intensity is less we will get. This graph in the reverse we need to study, that is from right to the left on x-axis, as the lambda value is decreasing, intensity is increasing. Intensity is increasing. At a particular lambda value, intensity will reach as a maximum. And then still if we are decreasing the lambda value, again that intensity decreases. Intensity decreases. According to classical mechanics, the radiation emitted by heated solids should be same frequency throughout all the temperatures, but intensity can change. Intensity can increase with the increase in temperature. So that means, students, when solids are heated, so as the temperature increases, the frequency should be same. It is emitted by the radiation which is emitted by the heated solid should be of same frequency, but intensity can increase. So according to the classical mechanics, when we are heating iron rod, then if it is at lower temperature dull red in color, it should convert into the bright red at elevated temperatures. But it should emit the same color, same radiation of same frequency, red color only it should emit. But it is emitting a different colors, which is not explained by the classical mechanics. But Max Planck explained this by using his Planck's quantum theory. Planck's quantum theory. Max Planck, a scientist's name is Max Planck, explained about radiation of black body. Max Planck explained about black body radiation the radiation is not continuous but it is discontinuous in the form of discrete packets are known as quantums. Radiation is not continuous, it is a discontinuous in the form of discrete packets are known as quantums. In the case of light, these quantums are called as photons. Energy of each photon is given by the formula E is equal to h nu. E is equal to, we can write nu as c by lambda, hc by lambda, where h is called as Planck's constant, h value 6.625 into 10 power minus 34 joule second, and c is velocity of light, 3 into 10 power 8 meters per second, and lambda is wavelength. Dear students, in the next class we will continue our discussion with the photoelectric effect. Thanks for watching.